Something your immune system relies on to spot friend from foe might be missing from your blood right now, and you may not even know it. Not switched off, simply gone, as if it had never been there. It can even turn pregnancy into a life or death risk, and a trait this costly should have died out generations ago. It didn't, and this led to various myths and wild theories around it. Roughly 1 in 15 people worldwide carry this gap, more than 500 million people. For decades, it was one of medicine's real unsolved mysteries, until scientists traced it back to an isolated population and found something stranger than any existing theory. Picture your red blood cells covered in tiny flags, thousands of them, each one telling your immune system what belongs and what doesn't. A constant, silent identification system running in your bloodstream right now. Most people's cells carry a particular flag called the Rhd antigen. If yours do, you're Rh positive. If they don't, you're Rh negative. What's actually happening at the genetic level to cause that gap is a story of its own, one that took scientists decades to fully trace. You'd expect a trait like this to show up at roughly similar rates everywhere on Earth. It doesn't. Among people of European descent, roughly 85% carry the flag and 15% don't. Zoom out to the whole planet though, and the picture flips almost completely. Closer to 93 or 94% of people worldwide are Rh positive because the missing flag is exceedingly rare across East Asia and much of Africa, and unusually common only in Europe. If you happen to be Rh negative yourself, that single fact already says something specific about where your own ancestry most likely runs deepest, long before any DNA test confirms it. For most of the 20th century, doctors knew Rh negative blood existed, but not why. And that gap in knowledge caused real, tangible fear in delivery rooms. If an Rh negative mother carried an Rh positive baby, the first pregnancy was usually fine. The danger came later in a second Rh positive pregnancy, when the mother's own antibodies, already primed from the first, could cross the placenta and attack the baby's blood directly, sometimes fatally, without anyone fully understanding why. At Columbia Presbyterian Medical Center, Doctors John Gorman and Vincent Frieda spent the 1960s chasing a fix, working with immunologist William Pollack, for a disease that had already cost countless families their children. The Division of Biologic Standards, the forerunner of today's FDA, finally approved it in 1968 under the name Rogam. The release date was set for June the 1st. A 29-year-old woman named Marianne Cummins, pregnant with her third Rh positive child, had already read about the coming treatment in the newspaper months before it existed as anything more than a hopeful headline. Rogam only worked if given within 72 hours of delivery, and her due date fell on May the 27th, just one single day too early to make the original release window. So her husband called in a favor through his contacts at the company producing it, and the release got moved up by 2 full days. On May the 29th, at Holy Name Hospital in Teaneck, New Jersey, Cummins became the first person in the world to receive it. It happened mere hours after the drug existed at all, closing a gap that had genuinely worried her for weeks beforehand. Medicine had finally closed one dangerous gap. It had no idea a second, far older mystery was still sitting inside that same missing gene. That second mystery wasn't hiding in a lab. It was hiding in a mountain range on the western edge of Europe. Rh negative blood was rare everywhere, but it showed up unusually often among the Basque people, living in the western Pyrenees along the Spanish-French border, in villages that had sat in those same valleys longer than most European nations have existed. They speak Euskara, a language with no known relatives anywhere else in Europe. Their Rh negative rate isn't just a little higher than average either. It's roughly double, sometimes reaching 35% in some villages, against a European average closer to 15 or 16. Alien ancestry, Atlantis, secret bloodlines running world events from the shadows. Every one of those theories fell apart the moment anyone actually tested human DNA against them. No hidden species turned up, no extraterrestrial markers. That left one real question the internet theories never actually answered. What was actually sitting inside that DNA to begin with? Decades passed before anyone could answer that. Then, in 2000, researchers Franz Wagner and Willy Flegel of University Hospital Ulm in Germany finally traced it down to something specific and testable, publishing their answer in the journal Blood. The RHD gene wasn't broken or malfunctioning in place, which is what most people would have guessed. It was gone entirely, cut out of the chromosome as cleanly as if it had never existed there at all. On either side of that gene sit two nearly identical stretches of DNA called rhesus boxes. Every so often, during cell division, those two matching stretches swap places incorrectly, an error called unequal crossover, and the entire gene disappears in the process, taken out whole. That should have closed the case entirely. It didn't. In African and some Asian populations, the same missing flag shows up through completely different causes entirely. Inactive genes that stayed physically in place but simply stopped working, silent mutations, hybrid genes built from mismatched pieces of RHD and its close neighbor RHCE. Different mechanisms arising independently in different parts of the world, all landing on the same visible result. Rh-negative blood was never proof of a separate lineage hiding somewhere in the human family tree. That explained where the mutation kept coming from. It still didn't explain how something this costly managed to stick around for so long. The answer, it turns out, has nothing to do with advantage at all. It comes down to luck, pure and simple. A trait this costly, tied to real pregnancy risk across generations, doesn't usually survive for thousands of years in a small, isolated population, since natural selection is normally far more efficient at scrubbing out anything that expensive to carry. This one survived anyway. When a population stays cut off long enough, chance starts to matter more than adaptation ever could. The founder effect means a small starting group can carry certain genes at unusual rates purely by who happened to be in it at the start. Genetic drift means those rates then wander randomly across generations, with too few outsiders ever arriving to dilute them back toward the average. The Pyrenees did exactly that for the Basques, acting as a wall as much as a home, while later migrations that reshaped blood types everywhere else in Europe barely touched them at all. Chance, not advantage, kept the gene alive. But chance alone doesn't explain why a trait this dangerous never seemed to cost the Basques what the math said it should. But luck may not be the whole answer here. In 2008, Jaroslav Fleger's team at Charles University in Prague found that Rh-negative and Rh-positive people respond differently to a common parasite called Toxoplasma gondii, one that infects an enormous share of the world's population without most carriers ever noticing. Rh-negative carriers in their study showed measurably slower reaction times once infected, a pattern Rh-positive carriers didn't share to the same degree. Other research finds weaker or inconsistent results, and nobody has fully settled the question either way. That uncertainty is worth sitting with for a moment. The trait might be surviving for a reason evolution hasn't finished explaining yet. One science is still actively chasing down. Somewhere between a molecular accident, a wall of mountains, and a parasite most people carry without ever knowing it, a piece of who you are took shape. Not because it was useful, but because of exactly where your ancestors happened to be standing when the odds rolled the way they did. That flag on your blood cells right now, raised or missing, is the reason scientists still can't close the file on this one.